Okay, so we're continuing our discussion of complex systems, or systems, linear systems that have complex eigenvalues, I should say. And here's a 4 by 4 example that I wanted to look at. This is also given in the book, but I wanted to just look at it more closely because I also want to introduce some software that we're going to be using in class. Um, so this is the system. You have a 0 by or 2 by 2 of zeros here, 2 by 2 of zeros here. Looks like the identity matrix is here, and here we have this 2 minus 3 halves 4 thirds minus 3. Okay, and so first of all, before we solve this, we need the eigenvalues and eigenvectors. And so I'm going to go ahead and bring in the code or the software we'll use, and that is the Octave Online is what it's called. And let's see, I'll bring this up a little bit. Maybe, whoops, then it just went away. I was just going to try to, I don't know if I can do this or not. Okay, we'll try to do this live as it is. Okay, so this was found by typing in octave-online.net. Okay, and so the commands that we type are going to be down here. And so first I need to type in this matrix. That's this 4 by 4 matrix here. So I'll call that matrix A, and I'm going to enter it row wise. So I'll have 0, 0, 1, 0, 0, 0, 0, 1 with semicolons in between. Maybe I can, I won't be able to show both of those at the same time. Maybe I can. Let's see. I'll do it this way. Okay. Maybe I should have set this up first. Okay, there we go. Now you can see them both. Okay, so now I'm going to type in this matrix, and I'll just type A equals square bracket 0, 0, 1, 0. I'm just leaving spaces. You can also use commas, and then 0, 0, 0, 1, and then 2 minus 3 halves 0, 0, 4 thirds. And just to verify that, I'll go ahead and put commas in this one, minus 3, 0, 0. Okay, and then just hit enter, and it should tell us what our matrix is. There's our matrix. And so now to see both the eigenvalues and the eigenvectors, we have to have two output matrices. So this is how you indicate output matrices. I want my eigenvectors in matrix V and my eigenvalues in matrix D, and that'll be equal to eig A. Let's see, I'll go ahead and output those V and D. So normally I would put a semicolon here, but if I do that, you don't see any output. By the way, up here you do see the variables. D and V are here. They're 4 by 4 matrices. So rather than do that, we'll just go ahead and suppress or leave off the oh, that's not a very nice way to see it. There we go. There we go. Good. Okay, so here's my my matrix. I need to pause this for a sec. Okay, I see I had an error. If you're following along in the book, right, these are not the right eigenvalues. So I see I made an error when I was typing this in. So here's the shortcut for getting your previous command in. If you use the up arrow key and keep using the up arrow key, you'll see all the different commands that we've typed so far. Right, and I could go down arrow key, up arrow key, and that saves you from retyping. And now I did get this wrong. This was supposed to be minus 2 positive 3 halves. Boy, I really copied it wrong. Minus 2 positive 3 halves, and then 4 thirds minus 3. Let's try that. Good. Let's try that one now. So now we'll do our eig A again. And there we go. This is the same eigenvalues that the book has. This is plus or minus 2i, and then plus or minus 1i, or just I. Okay, now the problem with MATLAB's eigenvectors is it's bringing these out as to have length 1 rather than to be nice numerically. So yeah, so that's kind of the trouble with using these. I'm going to go ahead and use the ones in the book when we come back to this. So let me write those down. Uh, Here's what we have. Maybe I'll pause this while I'm doing this so you don't have to watch me, and I'll be right back. Alright, so here we have our 4 eigenvalues and our 4 eigenvectors. By the way, I wrote this as v1, 2, but this is only v1, right? To get v2, I would have to negate or take the complex conjugate of the bottom two here. Similarly here, to get v4, I would take the negative of these two. Okay, and so what we're after here for our full solution is we want e to the rt times v, right? We want to compute that. And then we'll take the real part and the imaginary part as our two separate solutions. So first I'm going to do r1 and v1, and then we'll do e to the r3 and times v3. And so in this way I'm going to have 4 solutions, right? Real and imaginary. So this is just kind of what we're going to be doing next. So let's go ahead and do that. So let's go ahead and take r1 to be I, and then v1 is this vector. And so we'll take e to the it times 3 2 minus 3i 2i, which is cosine t plus I sine t times 3 2 3i's 2i. Good. Just continue on. Pretty straightforward at this stage. The book has a nice easy problem here. And then we have 2, whoops, that's supposed to be a 3. 2 cosine plus I times 2 sine t. I'm just multiplying that by 2. And then we multiply by 3i. So 3i squared is in front of the sine. That's going to be minus 3, so that'll be minus 3 sine of t plus I times 3 cosine of t. And then this one must have 2i times I, which is minus 2, or 2i squared, minus 2 sine of t, plus I times 2 cosine of t. Good. And so from here, this is one solution, and this is another solution. Okay. So similarly, we take the second one, and we take maybe I can do that over here, e to the 2it, and then 3 minus 4, 6 minus 8. Right, so that's going to be cosine of 2t plus I sine of 2t times my 3 minus 4, 6 minus 8. Normally I'm not going to go into this kind of detail here, but let me pause the video and I'll come back when I've computed this and we'll talk about the full solution. Okay, just to step you through the computations that I just made, we left off right here, and I was going to multiply this out, and I did that, and I got this expression down here. This is a vector. I guess I left my vector off. And so now I pull this piece off for one solution to the differential equation, and this is another. Okay, so I've got 4 solutions altogether, and so to get the full solution, I take the linear combination, c1 times this one, plus c2 times this one, plus c3 times this one, plus c4 times this one. And this is my full system of differential equations. What did I just say? That's the full solution to my system, the original system of differential equations. Very good. So they don't have to show up this way, although complex solutions, like we said before, always show up in conjugate pairs, but we could have had like 2 real solutions and 2 complex solutions to the characteristic equation. That's possible. Is it possible to have one real solution and three complex solutions? No. Why? Because complex solutions always come in conjugate pairs. Good. So I'm going to stop here and for this video, and then I think I'll probably go back to the um, other thing for the. I just wanted to mention briefly the case where we have um, a defective matrix. We're not going to work very much on defective matrices because yeah, it does get a little bit complicated. We have to do something called the normal form, Jordan normal form. And so rather than do that, we're just going to take a look at what we did in the 2x2 case, because that's what we'll do. Yeah, by hand. Otherwise we'll have the computer solve it. Okay, I'll stop here.